And so we can start our session, the software source code interest group. And today we have for the virtual plenary 18th, a very interesting subject, which is reproducibility. But before going to that, I'm going to show you a little bit of our agenda for today. First, an introduction to the interest group, because some of you are part of this interest group, but some are just new people that might not join after this session, but maybe you will. So I will introduce a little bit what's happening on the interest group and a bit of updates of the community, so you can stay updated of what happened in the community since our last plenary. Then we'll have a very interesting presentation by Pierre-Antoine Boutier about reproducibility and geeks. And finally, we'll have an activity around reproducibility, collecting use cases and tools. Everything will happen on the taking notes document, so you can find this on the chat, also in the program. It's the same URL. And let's go, let's start. So the software source code interest group, which was created in 2017, co-chaired by Neil Chu Hong, Julia Collins, and Roberto Di Cosmo. I'm here representing the VP18 coordination, but I actually coordinate the plenaries, and I see that this happens because software source code is very important and interesting during an RDA event. And since we don't have a lot of working groups and interest groups about software, this is good to have this space to talk about software. And so this is one of these objectives of this interest group is a forum for discussing research software within RDA. So please join in the interest group if you're interested in software. And to see a little bit what happens through the years since 2017, starting with a Birds of a Feathers session in Barcelona. Then we had some interesting subjects about metadata, ontologies, about identifiers. From this interest group started another working group called Software Source Code Identification Working Group that already completed its work. And after that, the Fair for Research Software Working Group, which is still working, also launched by within this group. And last session was about scholarly infrastructure and quality requirements for software source code. And so today we are going to talk about reproducibility. And for your information, on the first session in plenary 9th, the buff was called Software Source Code, Sharing, Preservation, and Reproducibility. And since then, this is the first time we are addressing the subject. So it's really nice to have it finally here. During this plenary, we have other sessions about software that you can follow in delay because most of them are already happened, but you can check out the videos. It is very interesting. And there are other working groups in this space, like the 4C11 Software Citation Implementation Working Group, which I've seen Martin Fenner here, one of the co-chairs of this group here with us today as well. But don't worry, Martin, I won't give you any work. I'm going to just say a few words later on about that in the updates. So why software source code? Because software source code contains the knowledge. Really, it is the item where us humans can read and understand the software. It is really, programs are really written for people to read and only incidentally for machines to execute. And the source code provides a view into the mind of the designer, which is a creation, a little bit differently than data, much more differently than data. And finally, the source code for a work means the preferred form of the work for making modifications to it. I will not tell you how hard it is to modify an executable. because it's practically impossible. Then in software, software in research, we find multiple facets. It can play different roles. It can be a tool, it can be a research outcome or a result, and finally, it can be the object of research. And the most complex situation is to find that software can be the three roles at the same time for different teams, where for one it's the outcome, for another it's the tool, and for the third one it's the object of research. And now I will ask you to go to our document, which I will put again in the chat for those of you who joined later, and answer our short icebreaker, not about the weather and where are you in the world, but what is the first software or hardware you have used? And there's a bonus question. What is your first programming language that you have learned or used? It can be, if you didn't start programming yet, the one that you would like to learn in the future. So I'm inviting you to go to this document up, which might appear in a way. And after writing your name in the participant list, it would be nice to know who was here. You go to this icebreaker and kind of answer this question. It would be nice to see. And it might be funny to see where everybody started when talking about software. So I'm going to give you just a few seconds to answer that, and you can comment other answers to interact on the document. And so I'm going to go back to my screen and apologize to Patricia that told me at the beginning to do some housekeeping. And I said, yes, I know to say that, but I forgot. So I'm going to say it now because nobody's talked yet. Please keep in mind that this session is recorded. And if you want to speak up, you will be able to at the end when we'll do our activities, but it is recorded. And if you don't want to be seen, you should turn off your camera. So I'm going to continue to the second part, which is some updates. And so first, it's not really an update, just letting you know I'm Warren Green-Peter from Software Heritage. And if you don't know yet, the Software Heritage Archive, it is here to collect, preserve, and share all software source code, not just research software, but all code, building a pillar in the 3 pillars of open science, as you can see here on top, with open source repositories and open access repository and open datasets repository. That is the aim. And if you want to use Software Heritage, you should. You can do it for many reasons. If you write code, you can save your code, but you can save also any code by just typing the Git repository in the Save Code Now interface, exactly like archive.org. So don't hesitate, save code now. And now that we passed on this commercial, I will go with the updates about the Software Citation Implementation Working Group. As I said to Martin, that is here. Thanks for being here. By the way, I don't know, maybe Neil is here as well. I didn't see him before. I know that Dan is not here. He sends his apologies. I'm not going to say whatever is written on this slide. You can check this from the slides later. I will invite you to the event. We have an event for 2021 in December. There's a deep dive session on the 7th of December at 5 UTC, and there will be some hack days before or after the event that we are trying to organize around software citation. And if we continue about the subject of software citation, I want also to invite you to check out the bibliothèque style extension for software. with a YouTube tutorial by Roberto Di Cosmo. This bibliothèque style introduces 4 new types: software module, software version, and code fragment. Here we have the examples of a software version and a code fragment. If you want to reference different granularity levels of your code or other software, it is very easy to use. So you should check it out if it interests you. And another update from the citation front. Since our last plenary, there has been some improvements in GitHub, which is a very large platform, and we are very excited to share this information that now citation.cff files are detected on a GitHub repository, and you can have this cite this repository functionality if you have a citation.cff file in your repository that will provide a BibTeX export with the type software, and also an APA citation copy that you can copy to your anything, wherever you want. Another good news is that those files, citation.cff, are indexed in software heritage. So don't worry about being indexed with the citation.cff file. I'm saying that because usually what I'm saying that go and use code meta, because this will make you, this will index your repository in software heritage, but both of them will do the same. It will be indexed. There are some advantages for code meta because you have more properties, so more flexibility in describing your software. And if you don't know yet, there's this code meta generator, which makes it easier to write. So the citation.cff is easy to write because it's a YAML file, but here you do have tools to create a code meta.json file. Next in the updates, we have the FAIR for Research Software Working Group. If you want the full update, you should go and check the video made earlier last week in the FAIR for Research Software sessions. There were 2 sessions, but if you don't want to go and check it out, which might happen, you should know that there is already, after a community review, a FAIR for Research Software Principles output on the RDA page, which you can cite with this citation and this DOI. We are working now on integrating the comments from the community review and releasing a version 1. Now it's version 0.3. And also we are working on 3 different subgroups around adoption and governance. So if you didn't join until now, you still can join the work. You can just follow the work, but it's interesting what's happening on this working group. So stay tuned. And if we need to stay tuned, we should stay tuned also in what's happened in the European Open Science Cloud around scholarly infrastructures for research software. Last plenary, we had a full presentation by Roberto Di Cosmo about this CIRS report. And I put the link to the video right here. So again, if you want to check it out, you should. But the reason I've put the slide is because there's a task force started in October 2021, which is called Infrastructure for Quality Research Software. And they will produce some results. Here is a link to the charter if you're interested in this work. Also keep track on that. And I think that the last update, last but not least, is about open science, open source in France. It's really exciting news that the national plan was released in July. It's the second national plan where software is very important and has a very big part in this plan. So I'm showing that to you. There also, I think there's a translation of the plan on the website, and we might use or might do a segment on national plans in general for the next plenary on this software source code interest group. So this is the end of the updates. And before going to the presentation, I know, Pierre-Antoine, you're very ready to present reproducibility. I'm just going to ask our participants to join in the notes and kind of answer this new question, icebreaker. Why are you interested in reproducibility? And I'm not going to go over to the notes like I did before. I'm going to stop sharing now. I will let you do this activity. Well, let you answer the question for kind of a few seconds, and you can continue answering while we have our exciting presentation. And I'm going to invite and welcome Pierre-Antoine Boutier, which is an HPC and numerical analyst, part of the GRICAD at the CNRS. He will tell us more about what that means and about reproducibility. So thank you, Pierre-Antoine, for joining. Thank you.
I will share my presentation. Okay, it should be okay. Thank you, Moran, for this brilliant introduction. I'm very glad to be here. Thanks a lot for inviting me to talk about this topic of reproducibility in the digital context. I will share in this presentation thoughts from a regional computing center point of view. So first, where I speak from GRICAD, which is a French structure based in Grenoble that provide infrastructure services and support in scientific computing and research data management for all research communities in Grenoble. And personally, I am a research engineer with a background in applied mathematics and scientific computing, and I'm in charge of the GRICAD support team. But I'm not a computer scientist, and I have not been involved in reproducible research for long. So maybe during this talk, there will be inaccuracy. And if you have remarks or suggestions, do not hesitate to tell. So the context element here is a quick overview of our infrastructure, just to say that we have several platforms, 3 supercomputers, 1 cloud computing platform, GitLab platform, Jupyter platform, etc., etc. And based on these infrastructures, we have to provide tools and supports to help students and researchers to produce the most robust knowledge possible in a digital context with computers, in other terms. And so to do that, we have to think about reproducibility. Let's look at a few common situations that I encounter every day. Some scientists want to compute statistics on a survey. Other one want to pre-process raw measurement data. Scientists want also launch even numerical simulation in various research fields. And others would like to analyze or visualize data sets, small or less big, etc., etc. The common point of all these activities is that they need a computer, obviously, and also they need data and software source code. I call that digital experiments, but I will explain later what I mean by these terms. I know also that some people consider software source code as data, as other data, and I'm not fundamentally, I don't fundamentally disagree with that, but to be the clearest possible in this presentation, I will make the distinction between both. So in the next slides, I will present some generalities about reproducibility in a digital context. It's mainly inspired by this presentation that is linked in this slide of Konrad Itzen. I think you will have a PDF after session. If you are interested about this topic and you don't know Konrad Itzen, I think you should look at that presentation. Even if it's in French, it's very understandable and very interesting. So this is a copy. This is the original. Now the copy. Why being reproducible? Mm, we can see reproducibility as a proof of rigor in our methodology, scientific methodology, that inspire confidence in the results that we obtain. If we look at a paper, for example, that present a non-reproducible result, we might think that the description of the methodology used to produce this result is not complete. Or maybe the author does not master enough the technique he used, or worse, there is an hidden error, or even worse, a fraud. And it's a problem. It's a problem because the confidence is important first for ourselves, or for scientists or engineer, to being at ease with their work, and it's important. Also to produce good work, I think. It's also very important to produce robust and fruitful, and I insist on this term, fruitful knowledge, in the sense that we can only discover new knowledge based on robust previous knowledge. And in fact, it's important to have confidence in scientific results so that the whole society can take hold of the scientific results. So I talk about reproducibility, but in fact, we can distinguish different types of reproducibility. The first one, the historical one, in fact, is the experimental reproducibility. It consists in redoing an experiment according to a published description, and we want to obtain sufficiently close results. Here we can see that the sufficiently term is more or less fuzzy. It needs maybe to be precise, but it depends a lot of the context. Maybe we can add here in this sentence, we want to obtain the most sufficiently close possible results to see we do our best to do that, and inspires confidence again. There is also statistical reproducibility. In redoing a study with a different sample or technique, we want to infer sufficiently, or the most sufficiently close possible conclusions. And then we can talk about computational reproducibility. Here, it consists to repeat a computation identically, and we want to obtain identical results. So, given that different type of reproducibility, let's go back to a few common situations that we encountered before, and what do we want? How the reproducibility in this situation. Statistics on a survey, we want computational reproducibility, because based on the same answer to the survey, we want to have the same statistic in output. And we want also statistical reproducibility. If we change the sample, if it builds in the same way, we want to infer more or less the same conclusions. Pre-processing raw measurement data, we want computational reproducibility. Based on the same data and input, we want to have the same results after the pre-processing. If we launch numerical simulation, it's an interesting example, because often, very often, numerical simulation, in fact, are the experiment of scientific work. So we want experimental reproducibility here, statistical reproducibility, but also computational reproducibility, to be sure that the different behavior we can observe in changing parameters is not due to the computer or how we deal with the computer. And in analyzing dataset or visualizing dataset, we want also computational reproducibility, given the fact that if we have the same dataset, we want to see the same curves, for example. So to conclude, when computers are used, computational reproducibility is at the minimum sought. It is a condition to obtain the other type of reproducibility. So I talk about digital experiments. Here is a diagram that shows what I mean by these terms. A digital experiment for me is in input you have data, you have a program. What I call program is the software that the scientist or student interact directly with in clicking buttons, in developing directly, in launching commands, etc. And around your program, you have an environment, software environment, operating system, dependency, etc. And you have an hardware environment. In this talk, I won't talk about hardware environment for the main reason is you can control a lot the hardware part of your environment. And you combine all this input to have new data in output. Okay, in this context, we want to see what tools and practices can help us to demonstrate rigor, remind the reproducibility definition through three requirements: transparent, readable, and accessible practice in the methodology we use to produce knowledge and hopefully reproduce it. So here we will try to answer to that question at the program level first. And the first answer is to use or develop open source program, open source software, and if possible, free software. In fact, it's the only way in the software world to meet the transparency requirement and also, in some cases, accessibility requirements. If you work with a closed source program, in fact, you have no guarantee at all that your program does what it says it does. Another point is with an open source program, the perenniality in time is more assured. If we look again at the closed source software, you have also no guarantee at all that your program will do in the future what it does now, and you are not sure of what it does now. So also initiative as software heritage are very important to enforce this point of perenniality in time. And I think as Moran has presented it, it's a very important initiative for us and for sciences in general. Most of closed source softwares are alternatives or can have alternative. It might take a bit of time to switch from closed source software and habits to open source alternatives or to build open source alternative. But I think we shall do that when we can. And finally, we should use also Linux-based operating system because it's really the focal point of the open source movement. And okay, your program is open source, but Linux is the only way to guarantee that you can have also your software environment, your open source software environment. But transparent is different from readable. Right now, what it does exactly. So you have to write documentation in the broadest sense of the term documentation. Here, it's to satisfy the requirement of readability. Documentation about the program that you are developing or using. And there are many ways to do that. You can describe use commands, algorithms that are implemented in the code. If you are developing your program code, you can document it by through code comments, or you can write an explicit source code itself. You can use Notebook to show how you have used data and your program, etc., etc. It's important to write everything that is necessary to understand your methodology at the level of your program uh, to reproduce it, in fact. And the last tool slash practice that I want to show is if you develop your program, is to use a software forge, a software development platform, to satisfy the requirement of accessibility. So for those who don't know what is a software forge, it's a set of tools mostly accessible on the web or through the net to manage and distribute source code. For example, GitLab, GitHub, etc., etc. It's based always on a version control system, and it allows you to manage your code properly. It's really good practice for a developer, but also to publish your code. And that's it's important, and to publish the associated documentation. And again, if you host your code on a platform that is registered in software heritage, this initiative will archive it and is pretty nice. Okay, so we have see at the program level what kind of practice we can set up quickly to tend to computational reproducibility. Now let's look at the environment, and more specifically the software environment, and why it's important. Your program requires always other softwares to run: operating system, executables, libraries, compilers, interpreters. In fact, it requires a lot more source code than just your program to run. And to ensure the reproducibility of a digital experiment, it must be possible to ensure the computational reproducibility of the whole software environment. And it's difficult, especially for neophytes, but also for experts. We can use documentation. You can have open source software. They are all hosted on GitHub, GitLab, etc. It won't be enough to reproduce your environment. It's too big. So we need tools. So this slide is an obligatory step in every presentation that talk about computing stuff. It's an XKCD slide that illustrates pretty well how a software environment can become a real nightmare. For example, with Python, we install different interpreter version, different library with different software managers. And in fact, finally, we don't know what we do when we use Python on our computer. It's a classical example, in fact. So how the computing center, us, what tool can we provide to users to help them to set up a proper software environment first, but more of that as we are in a research context to ensure the computational reproducibility of their experiments. So to go back to GRICAD here, again, several supercomputers, GitLab, nice to host your code and your documentation, as I said before, Jupyter Notebook to show how you use it, etc., etc. And we have also lots of users on this platform on supercomputers here. And we have a lot of heterogeneity. So heterogeneity of users, of required software environments, skills of supercomputers. We have three with different operating system, different purposes, different edges. So it's a complex task to combine these different constraints with the reproducibility aside. So we have to find the good tool. A bit of history now. Until 2015, we use module software, which is a very well-known software in computing centers to propose software environments. And as a users, you type module avail on the cluster to see the list of what software is available, what software environment is available also, and your module load to choose what you want. It's pretty easy. But there is a big disadvantages to that command, to that software. The first and the most important is module is very operating system dependent. It means first that it has a very poor portability. For a specific software, you have to create the module for each computer that you want, and for each version of the software, you have to create a new module. It's a lot of work, very poor reusability of previous module. There is a very little user independence. If a user wants a particular software, he has to ask to the administrators or support, and support has to create the module and make it available, and it can take time, etc., etc. Since modules are very operating system dependent, and given the distribution of operating system, there is a very marginal community aspect in the usage of module. And obviously, you forget about reproducibility with the system. Always, given the fact that operating system can vary a lot on different computers. So we want to find a tool that is easy to use for users. A tool that allows to install what you want easily in many different ways, and for us administrator or support, easy to reproduce with good properties to manage, to have a well managed dependency tree, to manage smoothly a version of a software, specific compilation option, etc., etc., with reproducibility, computational reproducibility in mind. And there is candidate. Here is a comparison table presenting different solution. Not all. For example, EasyBuild, SPAC, Nix, and Gigs. It doesn't show Conda or containers is here. But in fact, there is really here two family, EasyBuild and SPAC from a side, and on the other side, you have Nix and Gigs. The main difference between both is that EasyBuild and SPAC are still stick to the operating system. They build package up to systemlib. And we don't want that with reproducibility in mind. So Conda can be stored also in the same family that EasyBuild and SPAC, in fact. It's no very different. So we choose Nix and Gigs in our computing center. In this talk, we talk only about Gigs to be concise enough, but my main messages will be true with Nix also. So Gigs is an environment software manager, as I said, and could be or can be a Linux distribution, a whole Linux distribution. You can install it as a distribution or on top of another distribution, like we have done on our cluster. So directly, I want to show you some examples of Geek's nice features. But the first one is the operating system independent. You have isolated build and runtime environments, and it's very easy to have many versions of the same software, given the fact that build and runtime environment are isolated. And a simple user can install anything that is available among 20,000 packages for now, which is very nice comparatively to module. So it's a tool that is built from the beginning for software reproducibility. So all is done starting from the source. When you install a package, we talk in the open source context here, it will compile everything from the source, dependents included, with clever shortcuts to avoid to recompile effectively each time everything. But this is the main principle. And there is a nice strong link between Geeks and software heritage. As an example of this link is when you want to install a package that needs a source code which is no more available. If the source code was archived by software heritage, Gigs will automatically download it from software heritage to compile it, for example. Packages and environments are defined by simple source files. As Isabelle or Spark or Conda, it's not Gig-specific features, but it means that you can put these files under a version control system. And given that, you can go back easily, roll back easily to previous state of your file. And with gigs, also with Back, but not in the same way at all. It's easy to have atomic upgrade or downgrade of your software environment to navigate in time in your software environment. So in practice, if you are users, if you want to search a package, it's gig search command. If you want to install it, something, you have to type gigs install something. If you want to remove something, gigs remove. It's not a tutorial, it's just to show you that gigs is pretty simple to use. No more complicated than module, for example. Now, another example, more interesting in our case with reproducibility in mind, is how to set up exactly bit to bit the same environment across time and space. Here in this example from Bob's computer to Alice's account on a Greekcat supercomputer, for example. To do that, Bob has to type one command on his laptop, and as a result, he has a source file, source code file, sorry, and he has to send it over to Alice, who has to run this command on Greekcat supercomputer. And in doing that, if Alice installs the same packages as Bob, they will have exactly the same software environment bit to bit. And to finish the technical part, not so technical, but a bit, here is an example of a definition of a very simple package. Just to show you that it's quite understandable. You have the name version, the source, the hash of the source, and it's very important also from a security point of view. Gex control every time you install or build a package, it controls that the source are the good sources. So, for example, I think this mechanism is not in Conda, and I think it's a very important security check. Okay, there are a lot of parentheses also, but I will back on that just after. So what are the feedbacks from users? In fact, with a more or less good documentation that we have written, we didn't have major complaints. from switching modules to gigs. It was pretty smooth. However, we have very few power users. Most of our users are doing gig search, gig install, gigs remove, but they don't use advanced feature of gigs like gigs environment, gigs profile, etc., etc. But we are very happy with that for the moment. But we still have some problem with closed source software, but it's not from the user point of view, it's from the administrator and support point of view to fix this problem. So the feedback from our side is the first thing is gigs use a non-common language for us. It's a scheme, it's functional programming, and we do know very well functional programming in GCAD. And the learning curve was a bit steep for us. So it has taken time to develop packages at first. And yes, it can be still time consuming to package closed source software or binaries or software that have particular architecture because you have to write more scheme code. And I'm not yet an expert, so I'm pretty slow at writing a lot of scheme code. But we don't regret it at all. It's for a benefit. We have lots of existing packages, which is nice. We can share the packages that we develop to other super computing center. There are nice features that I didn't talk about, which is gigs environment, for example, which replies nicely, virtualenv for those who know Python, but extended to all language that you want, gigs profile, etc., etc. And finally, we have set up a tool that allows to our users to obtain computational reproducibility in their digital experiments. So I'm very happy with that. So to conclude here, I want to remind that reproducibility is a rigorous part of the methodology that we use to produce scientific results, to inspire confidence in those results, and to move towards reproducible research in the digital context. We have to adopt practices and tools that help us to satisfy the requirement of transparency, readability, and accessibility. As I said, at the program level, it goes through using open source program, write documentation, and use, if you are developing a program, software development platform, to publish it, to make it accessible. Yeah, at the software environment level, if possible, we should use gigs or NICs because these tools are made for that. Also, good coding practice, obviously. Just a last word about the gigs community. Currently, the HPC gigs community is growing in France. We are a few regional computing centers to test or to use in production gigs as a software environment manager. But I do not have a clear view of who is using it at the European level. So if you are interested, or if you know some people that are interested in using gigs or installing it in their computing center or on their laptop, and they want to get involved in the community, do not hesitate to contact me or to contact the gigs community through the mailing list, for example. I finished. Thank you for your attention.
Thank you, Pierre-Antoine. It was really, really eyes-opening. It was the first time I've heard you talk about gigs, and I did learn about the project before, but it was really, really interesting. Thank you very much. Now, I didn't see any questions in the chat, but if you have a question, you can maybe unmute yourself and ask your question live, so it will feel really like a live session, like we are not virtual people on a screen. So if you, I don't see any hand were raised, maybe Patricia, you see some hand raised that I can't see.
Nope. None yet.
Okay. Maybe we'll have more questions during our activity. Maybe I will ask just one question to set up this environment for a computational center. Oh, I see a hand raised. Just a moment. What would be a process to so? Just could we do it easily without your support, without the support of the Geeks community, or you think that it's preferable to pass through the Geeks community to set up this environment?
Sorry, can you repeat the question, please? I'm not sure
Yes.
that I have.
Okay. So if a research center wants to use Geeks or a team, would you think that it should that they can do that without the support of the Geeks community, or do you think that going through the community and kind of setting up, saying hi, we want to set up this set up the environment for ourselves, would be a better option?
At a local level, for a scientist on his laptop under a Linux distribution, I think he has just to read the documentation and following the steps, and it's pretty straightforward to install Geeks on the system. For an HPC computing center, if the administrator is a bit experienced, it's feasible. We have done that in KiCad without any support, external support, in following documentation and blog article on the hpc.geeks.info site. But if people encounter a problem or issue in installing Geeks, they don't have to hesitate to asking for help to the communities.
Sure, thanks.
It's a very charming community.
Excellent to know that. I see a hand raised. John, would you want to speak up? Can you unmute yourself? Okay. I think you just unmuted and muted. So we can't hear you. If you want to write the question in the chat, it might be easier for you. But if you want to speak up, you can try. Yes, yeah, the hand is still raised. I'm not sure if John would like to ask a question or not by chat or not by chat. Let's try again.
I see in the chat that during my talk, I haven't seen the chat during my talk, but I think there is a remark from Rolf saying that in scientific computation, there is no computational reproducibility. I don't know. I don't understand, in fact, this remark, Rolf. Maybe if you can precise it, it's interesting me. Sorry, I don't hear you. It's too low, the volume.
Sorry for that. Better?
Yeah, it's a bit better.
Better now? Oh, wait.
Yeah.
So I'm not sure whether we want to enter that discussion. It was just a remark because you defined computational reproducible as producing identical results.
Yeah.
And I believe that is simply not feasible. That does not exist.
You are floating arithmetics in head, or?
Yeah, sure. Because if
Okay.
if you run a non-trivial
Okay.
numerical simulation on the same computer 10 minutes in time again, you will not get the same result. You will get errors. And if your code is good, numerically stable, then you will get deviations in the order of machine epsilon. If your code is not good, you will get bigger errors.
Okay, I understand your point better. Maybe I should add at a certain precision level in my sentence.
I would say you should just aim for the same thing as in physical experiments. You should aim to reach sufficiently similar results.
Yeah. Okay, thank you for the explanation.
Thanks, Rolf. Maybe John has find a way to ask the question. I don't know. I will comment. I see it in the chat now. The USA National Academy use replicability as a term for a repeat experiment, whereas reproducibility is with respect to checking the calculation of the published work.
Yeah, I know the replicability term versus reproducibility. I know also there is often a confusion between these two terms, depending on people who talk. So it's the main reason that I don't, in this presentation, at least, I don't speak about replicability. If you look at the Conrad Insel presentation, he talked about a bit about replicability, but I prefer define my own term in this presentation and use them more clearly after. But yes, it exists and it's a use, yeah.
Thank you, Pierre-Antoine, and thank you, John, for the comment. Any other comments before we questions for Pierre-Antoine, who might leave us in a few minutes for our activity? Maybe we'll stay a little bit, but we'll see. So if you have any other questions, we will make sure to copy it also in the notes. We can answer it also asynchronously. So make sure that if you have questions, we don't want to leave you with questions unanswered. So I will thank you again, Pierre-Antoine, also in your...
You're welcome.
It was a great pleasure to have you here. And I will, yes, I see some hands clapping virtually. This is really hard to do when you're virtual, but yes, he merited very much. So now that we have, you're welcome, our reproducibility presentation, we can go back to our activities and our what we normally do during those these sessions, and I will share my screen, and maybe or if you are on the screen already with your two tabs open with the yes, I will share my screen. It will be easier for everybody, and especially for me. So I am sharing my screen, and I'm discovering that you did your homework. You have answered question number 2, which was an icebreaker question with why are you interested in reproducibility? And I can see that there's a lot of very interesting answers about verification, confidence in the results, confidence in the software, and really, I think that reproducibility is very important in this space. Something that I have neglected to mention is another working group, which is mentioned in the sessions, but I don't have a lot of information from this working group. Is the Cure Fair working group that also works a lot around reproducibility and with reproducibility. But since I'm very silent participant there, I couldn't gather enough information for you from this working group, but you should go and check out their session. I think it was also last week. I'm going to go ahead with our activity, which is in this part of the document. And we'll ask you to work because we have a few minutes left. Let's say let's not keep up until the half hour, because I know it's late for Europeans, even if it's comfortable for Americans. For us, it's really late. But let's try and work as for the last part of this session. So what I'm introducing to you for this activity is to collect some use cases about reproducibility. So we can take directly the use cases that are introduced in the why are you interested in reproducibility, or we can just name a few use cases that weren't discussed before. I see that since my view is that I have lost 2 people, but I hope that when I will stop explaining the activity, you'll go and do it. So you might ignore that name column and go directly to the actor column. And let me go to another box. And you can say a researcher, an administrator, or any other role that can act upon software source code or research in general that needs reproducibility. For example, with the environment, with a GIGS environment, and what type of, so this is the first part of the exercise. So in identifying the actors, maybe let's try with that. See if people do join me in the activity, or I will need to play it quiz. So here, let's try. I see a researcher coming up and being written. I can add a curator, because we have also curators that do work. And so the question is, do a curator will need reproducibility? So this is an interesting question. Will a curator need to reproduce some experiments, research experiments? I see another answer here, a reviewer. So the researcher wants to analyze measure data in order to publish. And I know that most of you that already participate in other working groups do collect use cases normally, but this is a good activity to see why we're here, why we're discussing this subject, why it is important, to see maybe also other roles, if it's a publisher or PhD student. So that's maybe less interesting than a publisher, sorry. But a PhD student is also important for research. We can't have research without PhD students. But a publisher can also be someone that needs the reproducibility tools to verify the code that is submitted with the publication, for example. And so the reason there's also a third column is to try and find tools or infrastructures or services that can ensure this, that the reproducibility can happen. But this part of the exercise is very difficult. So if you don't know any tools that are specifically directed to reproducibility, this would be almost impossible to answer without researching a little bit. And so it will be impossible to answer for this session. But I will keep this document open, and maybe we'll look at these answers later and see how we can find those two. I see already one answer on the third column, so I'm very grateful for this answer. A curation workflow tools. So yes, right, curation workflow tools, and this is right. So maybe not naming a tool, but saying what type of tool would solve this use case is a better way to go with this question. So thank you, anonymous red iguana. for this intervention. Again, there's the name column, but you don't really have to write your name. It's really if you want to share who you are, but here we really want to look at the use cases. So I see that there's a reviewer, an editor wants to check results of the paper they are reviewing, editing. Exactly, yes. So how do you, what type of tools or infrastructure could provide this answer for publishers to set up and review the code? Because it's true, you get a submission, might be on a different environment that cannot run on the environment of the publisher, of the reviewers. So what could that look like in terms of reproducibility of the paper? So also the question is, do publisher have the possibility to check the validity of the results of source code that is submitted with the paper? I don't know if we have this kind of answers here, but this is good subjects to review. And we have the PhD student wants to test several options in his research and data analysis process also after a paper or his PhD has been reviewed. Exactly, testing options. So that this is also for the PhD student, but also the researcher when going, well, starting the research or even not starting it, just analyzing what's happening, the options, the tools. So what can be a good tool for that? This is a question. I see that there are also other tools there. There's the first one, the researcher that wants to analyze, measure data in order to publish the result. So the answer for that, Forge platform documentation using geeks to set up and describe environments. So yes, this is a good tool that can be used for measuring the data when publishing the result. I'm going to go further down. We have the funder wants to be sure that funded projects produce rigorous outputs to protect their scientific investments. But this is a good use case, but a bit different from the reproducibility to really see the thing work, but just know that it is sound. So maybe the same tools can apply, but maybe other tools, maybe simpler tools can apply as well. I'm not sure. This is a good use case. Then we have the instructor wants to teach methods using real-world examples of reproducible research. Yes, so that's maybe the notebook can be a good tool for that to kind of teach, but then are notebooks sufficient for, well, we need more than just the notebook, because in reproducibility we need much more than that. I think that Pierre-Antoine is unmuted. Maybe you want to say something about notebooks.
Yeah, just I hear very often that my notebook is a good way to produce reproducible research, and I think it's clearly insufficient. For me, notebooks is a very good tools to document your methodology, to explain what you do, or to explore also. But it's not a very good tool to attain computational reproducibility, in fact.
Excellent. Thanks for jumping in on that. I agree. I think that it's not enough for reproducible research, but there's actually, to reproduce something, we need a real, as you explained in your presentation, a net of things that with one tool, maybe even it's not achievable to just use one tool to do so. So I completely agree. I have another use case, the archive, make sure digital materials can be used in the long term and reproduce results. Oh, so this is a fun one for me. Is the archive the one that wants to make sure that it can be reused? Because here we are talking about using the digital holdings. So this is a good question. How do we want to reuse that? If we archive executables, just archiving the executable is not enough, right? Because if we don't know what we're talking about when we just have the executable, we don't have the environment to execute them or the hardware, which can be emulated, but we need this infrastructure to know what it's doing and to reuse that. So I see someone putting easy as an option. Yes, easy is a good, easy for those of you who do not know easy. Easy is emulation as a service. It's a tool, but it's really a project by the SPN, Software Preservation Network. Very interesting tool that they created to really emulate hardware and environment on this easy platform. And there's also the other proposal, ReproZip, and I have also seen that tool, which is really nice as well, from the New York Library. Really, you should check that out. And since you are looking at those tools, we can go to our next question, which is the one where we name the tools, and this way we will have this pool of tools, this kind of collection, where we can copy the links there from Easy and ReproZip to the tools for reproducibility, and have some description. And if you have some comments about those tools, because you use them, because you know them, this will be a very nice place to hold and collect tools. So I see we have just 15 minutes left, which can seem like a lot of time for us Europeans, since I'm in the dark now. I have my lamp, but almost dinner time. I'm inviting you to this tools table to kind of complete tools. I see also comments from Limor Père. Limor, do you want to say those comments live? If
Sure, happy to. You can hear me okay?
Yes, perfectly. Thank you.
Hi, everyone. Yeah, I just want to point out that the ACM, the Association for Computing Machinery, did a series of community conversations about reproducibility, and it's all documented on a blog on their website. And there was one that was dedicated to, we called it solutions, but it's tools really. And so it was more questions about, what do we want to know about tools, or how can we think about them? Where is there an inventory? You know, what are the key questions? So I just wanted to point that out. I don't think there's specific recommendations, although there's some examples, but it's more sort of like, how do we think about tools for reproducibility?
Excellent. Thank you for sharing that. I haven't seen this blog post, and I'm really interested. So thank you first from myself, and I believe that also the rest of the group here will benefit from going to this blog post. So we can also copy that to the notes. I'm not sure it will be a lot of well, really functional to kind of copy all the tools from the blog post. So just I will take this link. But if other people here have other tools they know, they've met in digital sense of meeting, and they want to share with the group, this is a good way to share it with the table in our short and small activity. I know that I imagine there are other working groups, even your working group, Limor, about Cure-Fair, you must have a collection of tools, or maybe a better organized table that names tools for reproducibility. And I'm not sure if Cure-Fair does guidance or only kind of recommendations.
We have a list of, we're calling them practices. It's actually people who are doing Cure-Fair work, so people who are curating for reproducibility. And within that, there are some tools that might be used. I don't believe that we have an independent list of tools at the moment, but that's actually, yeah, that's a good idea. I think there are several directions this is coming from, so it might be good to think about such, creating such a list.
Excellent. So exactly, I think we found something that we can share also between the groups, between the interest group and the working group, maybe on a wiki page in the RDA. I'm not sure if that's the best solution, but it might live longer than in a Google Doc to have a list of suggested tools in this the reproducibility space, even if it's for curation or research. Sharing this with the community, with the RDA community, I think it's important. Thanks, Limor, again, for intervening. So I see that you are not people here writing tools, maybe because you don't know tools, but I will do the work afterwards to copy the ones that you've listed in the first table and put it also in the second table, and we'll see how we can organize maybe a curated list of tools. This would be a nice way to go. So I'm going to end this part of the activity and go straight to the last part of the activity, which is the feedback page. And in the feedback page, I'm going to show you what you need to do. So first, there are a few themes here already listed, but you are free to propose other themes or subjects for next plenaries. It might not be the next one in 2022, in the beginning of 2022, but for other plenaries, because the next one, we do want to do something about national plans. If you have coming from a country with a national science or research plan where software is visible, please reach out to me, and we will have you also presenting at the next plenary. But you can suggest other themes for the plenaries after that, or other subjects that you are interested in as a software source code interest group. It will be nice to know what you're interested in, so we can add this in the mailing list subjects that we are sending from time to time. And then the other part of this feedback page is real feedback. What would you like us to keep, and what would you want us to improve? If it's more external speakers, like we had Pierre-Antoine today, which was enlightening. So really, I would say maybe having more of that. But I leave you to it. I'm going to go back to my presentation. So I was doing this slide with you, with open questions for feedback to answer on the notes. And you can always join us in with the mailing list, the Software Source Code Interest Group. We are not, we don't send a lot of emails, so don't worry about that. It's quite reasonable. And I will thank you all for joining. I see that we do have 10 minutes, so I'm thanking you, but I'm also proposing a small brief time for questions if it's about maybe about the presentation. I'm not sure if Pierre-Antoine is still with us, but if it's large questions, I see he is still with us because he unmuted himself.
Yeah,
but
yeah, I'm here.
good to know that you're here. But for any question, if you have any question about the interest group, about software, about the updates that I've did in the beginning, or events or ideas that you want to share and you want us to explore as an interest group, this is the time.
Maybe Moran.
Yes.
I was surprised during the presentation and the question after to not see anyone talk about containers, but in fact I see that containers is a proposed subject for the next session. I can talk 2 minutes about that if it's necessary, if
Yes,
it's an option.
yes. Yes, go ahead. We have the time, and yes, containers are also a subject that comes really frequently when we talk about software in the research space, and I would love to hear your thoughts about that.
Okay. How to start? Yeah, I hear very often that containers are a very good tool for reproducible research in a digital context, obviously. I think it's a mistake. In fact, if we look at how images are built with Docker or Singularity, or they are not built in a reproducible way. But in fact, there are two parts in a container system like Docker or Singularity again. There's the build part, the part that build image, and I think this part is pretty bad at produce reproducible software environment, in fact. And the part that run your images. And fortunately, again with gigs, I think I'm a commercial, you can replace this pretty bad from a reproducibility point of view. It's very good for other technical subjects. But this part of building images with Docker, you can replace it with gigs or Nix in one command to create a perfectly reproducible image that you will run after with Docker or Singularity. And I think it's pretty good compromise to deal with reproducibility and container.
Thanks, Pierre-Antoine. Yes, it's a real challenge. And I think that people imagine that containers will be kind of maintained forever, and it will be easy because it's in a container. And so we'll deal with this with the future me will deal with this, or the future people in the. And so I agree that containers might not be the solution that people think it is. If we have other people here that want to react to that. Yes, Pierre-Antoine, you said.
No, just to finish, if people are interested in my presentation, I have some backup slide about this topic, so you can download after the session the PDF and just look at it quickly.
Excellent, thank you. I see that Martin, you have your hand raised.
Oh, I just want to second that containers are lovely for many reasons, but I would not bet on what we do with containers and how in 5 years. It's such a fast-moving field, and sort of many of the big players in the field are not thinking for the future, for what things look like in 5 years and 10 years. And just give a random example, Docker recently changed to license for the client, which is, you happen to work for a bigger company now, costs you money, so it's not really open source anymore. And also there is, of course, many different ways how you can run containers. There's probably half a dozen ways at least for running this. So I think it's very nice, and but reproducible going forward, I would not bet on containers. Maybe the specific version, if you tell everybody they should use these tools and follow these rules to build containers, then we can sort of have an archiving way where we feel confident this will still run in a few years.
Excellent, thanks, Martin, for kind of responding to that. It comforts me with my personal beliefs as well, so it's always nice. Any other comments, questions on, well, you can comment containers as we did already, or ask anything. We have 4 minutes left for any question that you have. Let's see if we have some other question, comments. So as I said also earlier, there's the FORCE 2021 event in December. So that will be the most recent, well, the next event after this one, that where we deal with the research software in a citation context. Maybe the Fair for Research Software Working Group will do some workshops on guiding you through implementing these FAIR principles, even though I'm not sure that we resolved how to implement those FAIR for Research principle. We'll see about that. I see, Martin, you have still your hand raised, but I think it's your hand from before, so not a new hand raised. And so with that, I will tell you, everybody, to have a nice continuation of wherever you are and whenever you are. For me, it will be evening, but it can be morning or afternoon for you, or very, very late at night. I don't think we have some Australians here, but hey, maybe. So thank you for joining us. It was nice to have you all here and to work on the document. And thanks to Pierre-Antoine for his wonderful presentation. Really, I think we should do it more, having people come and share their experience here. I personally believe we can all learn from that. So again, have a great day, afternoon, evening. Bye.